Welcome to the unbelievable story of the atom. Everything around you, your phone, your food, your body, your chair, even the air you breathe, is made of atoms. But scientists didn't discover atoms in one day. So today, we are traveling through time to understand the complete history of the atom in the easiest and funniest way possible. Let's begin our atomic journey. Back in 1803, a scientist named John Dalton gave the first proper atomic theory. Dalton looked at matter and said, everything is made of tiny particles called atoms. Now according to Dalton, atoms were like tiny solid balls. No holes, no charges, no particles inside, just hard little spheres. Basically, Dalton imagined atoms like tiny cricket balls floating everywhere. His model became famous as the solid sphere model. Dalton also said that atoms cannot be divided or destroyed. He believed atoms of one element are different from atoms of another element. For example, hydrogen atoms are different from oxygen atoms. And when atoms combine together, they form compounds. Like hydrogen plus oxygen becomes water. Honestly, for that time, Dalton's theory was revolutionary. Scientists were impressed. Everyone was like, wow, this guy cooked. But science has one rule. No theory survives forever. A few years later, another scientist entered the scene and completely changed the story. His name was J.J. Thomson. In 1897, Thomson performed a famous experiment using something called a cathode ray tube. Now imagine a glass tube with electricity passing through it. During the experiment, Thomson noticed mysterious rays moving inside the tube. And these rays were attracted toward the positive side. That meant these particles were negatively charged. Boom! Dalton's solid atom theory started breaking apart. Thomson had just discovered the electron. The atom was not indivisible anymore. There was something inside it. Thomson called these tiny negative particles corpuscles, but today we call them electrons. Now Thomson needed a new atomic model. And this is where things became deliciously weird. He imagined the atom like a plum pudding. If you don't know plum pudding, just imagine a chocolate cake with chocolate chips inside it. The positive charge was spread everywhere like the cake, and electrons were embedded inside it like chocolate chips. This became famous as Thomson's plum pudding model. Scientists accepted it for some time. But then came a scientist who absolutely destroyed this model using gold foil and alpha particles. His name was Rutherford. In 1909, Rutherford and his students performed one of the most legendary experiments in science history. They fired positively charged alpha particles toward a very thin sheet of gold foil. Now according to Thomson's model, these particles should easily pass through the atom because the positive charge was spread out evenly. So Rutherford expected all particles to move straight. Simple, easy. But science said, plot twist. When the literally said it was almost as surprising as a cannonball at tissue paper and having it bounce back. So what did Rutherford conclude? He said the atom must contain a tiny, dense, positively charged center called the nucleus. This nucleus contained most of the atom's mass, and the electrons moved around this nucleus. Thus, Rutherford gave the nuclear model of the atom in 1911. According to this model, atoms have a small dense nucleus. The nucleus is positively charged. Electrons move around it and most of the atom is empty space. Suddenly, atoms looked less like pudding, and more like a mini solar system. But Rutherford's model still had problems. Scientists were confused about how electrons stayed in orbit without crashing into the nucleus. Then in 1913, Niels Bohr improved Rutherford's model. Bohr said electrons do not move randomly. Instead, they move in fixed paths called shells or energy levels. Think of it like floors in a building. Electrons can stay only on specific floors. They cannot exist between floors. And if an electron gains energy, it jumps to a higher shell. If it loses energy, it falls back down. Basically, electrons were now doing parkour inside atoms. This became the Rutherford-Bohr model. Scientists loved this idea because it explained many observations about atoms. But wait, another mystery appeared.